Okay, we have our continuation of solving linear equations with a single variable, and it's just because I ran out of time with the last lesson. So, continuing on, remember we're trying to be able to solve for a single unknown variable when we have an equation that looks something like 5x minus 2 equals negative 9 plus 7x. But we actually did this last time, and just to speed through it super quick, remember we added 2 to both sides, and then we subtracted 7x to both sides. And remember, wait, did we subtract 7x from both sides? Oh, this was 8x. I'm sorry, I got confused there. I don't know why I wrote 5. 8x, okay. So we subtracted 7x from both sides, and we ended up with x, and the 2's just went away, and we ended up with equals negative 7, and that is the answer. Okay, so going on to another problem is 5n plus 34 equals negative 2 times 1 minus 7n. So Abigail, what's something that you noticed that's different about this one as compared to the previous examples?
It has
That's right. And what did we learn from our combining like terms? That the first thing that you should do in a problem that has parentheses like this. That's right. That's right. You should use the distributive law to get rid of the parentheses. So when you're trying to solve an equation like this, we need to get rid of the parentheses because we need to be able to deal with the ends. For example, if I tried to add, you'd think that I might want to add like 7n to both sides, right? To get rid of this. But it wouldn't work because you're not allowed to add 7n outside the parentheses. I mean, if you do add 7n, you can do whatever you want, right? You can do whatever you want as long as you do it to both sides. But if you added 7n to both sides, you see, it would not cancel this out because this negative 7n is being multiplied by negative 2. And this one is not. So you have to multiply out before you do the other steps for solving. So what would I get on the right here if I multiply it out? Let me just write the left side again. 5n plus 34. And on the right, what would I get, Abigail? Very good. Yes. And what minus a negative 14n? That's right. So let me just write plus. Whoa! Sorry about that. Okay. Let me just write, got a little technical difficulty there, plus 14n. And so when you see negative 2 times negative 7n, you can just think a negative times a negative is a positive. And it's 2 times 7 is 14. Don't forget to keep the n in there. So now this problem looks a lot more manageable. So which side, Abigail, do you want to get the n's on? Right side. That's probably a good idea because I've got more n's there anyway because I got 14 of them and only 5 of them there. So what I'm going to do is I'm going to subtract off 5n from that side, and I'm going to subtract off 5n from that side, because I have to do the same thing on both sides, right? That's the rule. And then, actually I could do 2 steps at once if I wanted. I could add 2 to this side and add 2 to that one. And when I combine, whoopsies, sorry about that. When I combine, sorry, I'm kind of totally messing up here. When I combine those steps together, I end up with 0n, and then here's 36 equals 0 plus 9n. Now, am I done now, Abigail? Am I done? No. Whoa, sorry about that again. I apologize profusely. Okay, 36 equals 9n. Does that tell me what n is? Not quite yet. So what do I need to do next? I That's right. So I could divide both sides by 9, if you will. Negative divide by 9 and divide by 9. So that gives me that n on the right-hand side is equal to 4, which is a nice number. N equals 4. Let's just check, because it's a good practice to get into. to check to see if n equals 4 works. So I plug in 4 for this n, and I plug in 4 for that n, and we'll see if it works. What another color here? Orange, maybe. Okay, 5 times 4 is 20. The question is, does 20 plus 34 equal negative 2 times 1 minus 28? Oh, this is a little weird. 1 minus 28 is negative 27. Negative 27 times negative 2 is 54, actually. So this side here is 54, and that side is 20 plus 34. It is 54, so we have a match. But of course, because math always works if you do it right. All right, one more example here. We've got a negative 3. Oh, let me give myself enough room. I've learned that lesson from the last one. Negative 3 times 4x plus 3 plus 4 times 6x plus 1 equals 43. How about that one? Now what do you notice is different about this one, Abigail? You have all the x's on the left side, and I've got 2 parentheses. So what do you think the first thing to do is? Yep, using the distributive law. So here I get negative 12x. Negative 3 times positive 3 is negative 9. And then I've got 24x, and I have to multiply the 4 by the 1, which gives me a 4. And then on the right I have a 43. So let's, since we all have all the x's on the left already, let's move all the other numbers to the right. So I can actually do this in one step. You can do it in multiple steps if you want, but I like to kind of just say, okay, I'm going to add 9, and I'm going to add 4. So that means I need to add 9 and 4 on the right side too, don't I? Let's just do that up to that point, and then we'll continue. So I still have my negative 12x. I've gotten rid of my 9. I have my 24x. I've gotten rid of my 4. Whoopsies, made a mistake there. This should be a minus 4, because a positive 4 would not get rid of a positive 4. And so this on the right side needs to be a positive. I don't know what the bug is in this program that's making these lines like that. Anyway, that's a minus 4. I need to try to erase this. Whoa, this is horrible. All these terrible lines are... Whoa, the more I do, the more lines come. Ah! I better just stop that. I'll have to do some programming. Okay, 24x equals 43. Okay, I got a plus 9 and a minus 4. Okay, so that's altogether a plus 5, so that's 48. Okay, now, what do I do on the left here, Abigail? Add what? That's right, and what do I get? 12 what? 12x, very good. This is like combining like terms. If I have negative 12 of the x's and I add 24 of the x's, I end up with positive 12 of the x's. And that is going to equal 48. So the last step is to then just divide by 12 on both sides, and I end up with x equals 4. Whoa, it's the same answer as the last one. I sure hope this is correct. So let's plug this in, switch to my orange color, and I end up with negative 3 times 4 times 4 is 16. 16 plus 3 is 19. I hear somebody rummaging through the cabinet back there. Plus 4 times, okay, 6 times 4 is 24, plus 1 is 25. The question is, does that equal 43? Ooh, what do you think? Is it going to equal? Negative 3 times 19, I think that's negative 57. And then I've got 100 over here. Oh, Liam's making cheese and crackers. Okay. Thanks for telling us. Negative 57 plus 100. Is that going to equal 43? That's the question. And, yep, it does. Of course, because math always works when you do it right.